Alright, here we go. We're going to solve some systems of equations by graphing first. So a little bit related to what we were doing, but we're actually going to graph these two equations. So I'm going to remind you a little bit about how to graph a parabola. This one has, and what I would maybe suggest is if you don't know how to graph an equation, simply make a table for it. Okay, so you can do that. I might even show you here for a second. If I plug in, let's say 0 into that equation, well, that would be 0 squared minus 3. So 0 minus 3, so I would get a negative 3. I'll go ahead and put that point on. 0, negative 3. Let's plug in 1 and see what we get. 1 squared would be 1, minus 3 is negative 2. Okay. Oops, graphed that in the wrong spot. 1 comma negative 2. Okay, now this parabola has a vertex at 0, negative 3. Okay, so you're going to have to review some of how to graphing to find how to find the vertex of a parabola, but I also know that this is simply the parabola y equals x squared and moved down 3 points. So from here at 0, 0, it's moved down 3. So if I plug in negative 1, what I'm saying is I'll get negative 1, the whole thing squared. Negative 1 times negative 1 is 1, minus 3 is another negative 2. So my parabola is symmetrical when I graph it. Okay, let's plug in one more, 2. So if I plug in 2, I get 2 times 2 is 4, minus 3 is 1. So 2 comma 1. So parabolas, if the a value is 1, I'm going to go ahead and put the symmetrical point over there, by the way. If the a value is 1 here, okay, then I have this pattern here where from the vertex I can go over 1, up 1, over 1, up 3. I could do that same thing on the left, over 1, up 1, over 1, up 3. My next point would be over 1, up 5, over 1, up 7, and so on. So that's the pattern of graphing a parabola. Okay, so I'm going to draw that in there. Now I'm going to graph this other line. Some of us freak out when we see this, just the y equals a number, but if I follow that rule, and I know that this is the y-axis, I'll go down to negative 2, and I'll put a little point there. But I need to figure out how to graph a line with that, and the only way to do that is if all the y's are negative 2, then that means that I have to be along that line y equals negative 2. So my line ends up being horizontal here, but if you think about each of these points, the y value is actually negative 2. So it makes sense that it would be a horizontal line here. Okay, so there's that line. And like we learned in our last video, we know that the solutions are where the two graphs cross. So my two solutions are at 1 comma negative 2 and at negative 1 comma negative 2. Now I could have also written that my solutions are x equals 1, y equals negative 2, and then my other solution would be x equals negative 1, y equals negative 2. So those are my two solutions for this system of equations. Again, if I plug those numbers in to my two equations, I'll get two true equations, and I dare you to try it. Okay, so let me show you one more. This one has a little bit crazier of a parabola. Okay, so I'm going to go ahead and find the vertex for this one and get started there. It's also possible to factor this if you are into factoring or have done that in the past. But I'm going to go ahead and get the vertex here. Okay, so the vertex for any parabola is found by doing negative b over 2a, and then you plug in whatever x value you got to get the y value. Okay, so that's how you find the point for the vertex. Remember that a, b, and c are the coefficients in the standard form of the equation. Oops, I want orange here. Okay, so I'm going to plug in negative b, which is negative 1, opposite of b. B is 1, so plug in negative 1. 2 times a, well, a is 1, so it'd be 2 times 1. Okay. And we'll do the y value in a second. I don't know what that is. So negative 1 over 2, is negative 1/2. Ooh, bummer. Okay. Well, if I plug in negative 1/2, that's how I'm going to get my y values. So if I plug in a negative 1/2 here, maybe I better do it. Square that, plus a negative 1/2 here for x minus 2. Okay, negative 1/2 squared, that's going to be a positive 1/4. I'm running out of room for all my work here. Plus a negative 1/2 minus 2. Okay, 1/4, running through some review on fractions here, minus 2/4 to get a common denominator. Okay, I end up with negative 1/4 minus 2, again, common denominator, negative 1/4 minus 8/4, negative 9/4. Whew! Alright, let's go ahead and put that point in. Okay, well, first of all, let me just point out that I can go ahead and write my negative 9/4 in here. This is what I got for the y value. So this is my vertex, right? So negative 1/2, negative 9/4. So negative 1/2's right here. Negative 9/4 is the same as negative 2 1/4. So that puts my vertex right here. How strange is that? Well, okay. So there's my vertex. Let's go ahead and plug in some points around the vertex and see what we get. And I'm going to choose to plug in easy ones, not fractions. Okay, so this table is still for this equation. Plug in 0. See what you get. You get 0 squared plus 0 minus 2. 0 plus 0 minus 2, well, that's negative 2. 0, negative 2. Now again, remember that my parabola is supposed to be symmetrical. So if I went 1/2 to the right of the vertex, then I can go 1/2 to the left of the vertex and get a similar point. Okay, and so now I'll just plug in one more. I want to try to get as much as I can on here. Let's plug in 1. 1's easy. So 1 squared, I'll go ahead and write this one in. 1 squared plus 1 minus 2. Well, that equals 1 plus 1 minus 2. 2 minus 2, oh, that's 0. Interesting. So again, I'll have a similar point on the other side of the vertex. I'm going to go ahead and stop there for now. Hopefully that's enough to get my solutions, because I'm trying to make the graphs cross. I could keep going, but I'm just going to stop there for now. So, okay, we got a parabola. Done with the hard one. Okay, let's graph the other one. Our lovely line. Okay, most of these that you're going to graph in the lesson are going to be like this, where you've got a quadratic and a line. So for this one, my slope is negative 1. Remember, y equals mx plus b, slope formula, or slope-intercept form. The y-intercept is here, it's the b term, so plus 1. So the y-intercept is 1. Slope is negative 1 right here. So go down 1, right 1. Down 1, right 1. Or I could go up 1 and left 1, because I've got my rise over run and I want to do a negative 1 here. Okay, so here we go. I'm just going to keep graphing this. Okay, it looks like I'm crossing at one point, right? That point is right here at 1, 0. So that would be one solution. But I would have crossed if I had kept graphing my parabola. So dang, I didn't graph it quite enough. So let's go ahead and keep going. Remember, I was telling you that there's kind of this general rule that you can go over and up, but I mean, I'm not really sure where it's going to land. Hopefully it lands on that point, but I don't know. So maybe I can plug in negative 3 just to see. Okay, so let's plug in negative 3. Let's do negative 3 squared. Remember, I'm plugging into my orange equation. Plus a negative 3 minus 2. Okay, so negative 3 squared is 9, plus negative 3 minus 2. It looks like it might come out nice. 9 plus negative 3 is 6 minus 2, which is 4. So negative 3, comma 4 is a point. Let's put that on. Negative 3, 1, 2, 3, 4. Whew! Thank goodness it crosses perfectly at a point that we don't have to estimate. Because that's the bummer about graphing, is if it didn't, then we'd probably need to find a different solution method, different solving method. Okay? Because we want to know exact solutions. So if we can point that out on the graph exactly where it crosses, then that's great. So negative 3 comma 4. So these are my two solutions now. So that second one took a bit longer, but it's still good practice. It's good practice for graphing. Some people really love graphing. Some people it's not their favorite method for solving a system. So you choose what you like, but go ahead and use this to help you on your quiz. Alright, and then get ready for our next video, which is going to be about substitution.